This next video in Solutions to Number-Related Problems tackles real-life situations using applications of linear equations. You are in Mathematics of Engineering. There are 7 real-life situation problems to be solved in this video. Real-life situation problems are more common and they are easier to interpret than with numerical problems. The same procedure of assigning variables for unknown parameters will be the initial step. More importantly, proper interpretation of the equations are to be presented. With correct linear translations, form equations to use in order to solve the unknown parameters. For the first problem, 96 golf balls were picked up at the driving range and placed into 2 buckets. One has 28 more balls than the other. How many golf balls are in each bucket? We assign X for the first bucket, assuming more balls are in it. Y is in the second. Next is to identify the relationship of both variables, X and Y. It was stated in the premise that X would be equal to Y plus 28. Another equation to be observed is the total number of balls placed in both buckets, totaling to 96. Write this as X plus Y as equal to 96. From the previous interpretation, X is equal to Y plus 28. So convert all variables into Y to have Y plus 28 plus Y as equal to 96. Simplify the terms and get 2Y plus 28 as 96. Transpose 28 to the opposite end and get 2Y as 68. Take Y by dividing the equation by 2 and get Y as 34. This is the number of balls in the second bucket. X is solved as Y plus 28, which is then 34 plus 28, which is equal to 62. The next problem discloses a basketball team who played 32 games and won 3 times as many games as it lost. How many games did the team win? Assign X as the games won and Y for the number of games lost. Relating games won and lost, we get X as 3Y. Another equation includes the total number of games, giving X plus Y as equal to 32. Minimize the variables, so use X as 3Y. Then get 3Y plus Y as equal to 32. Collect similar terms and have 4Y as 32. Divide both sides by 4 to get Y as 8. This is the number of games lost by the team. For the number of games won, use the equation X as equal to 3Y. Plug in 8 for X and get X as 3 times 8. X is then simplified as 24, the number of games won. For the third problem, 160 guests attended a banquet. 3 servers provided their beverages. The first server helped 3 times as many people as the second server, and the third helped twice as many people as the first server. How many guests did each server help? With 3 unknown variables, X is assigned for the first server, Y for the second, and the third will be Z. Identify the relationship of variables. First, The first is x equated to 3y. The second relationship is the third, equated as 2x. We have also identified x as 3y, so we get z as 6y. The other equation from the premise is the total number of guests served. Denote this as x plus y and z as 160. To keep the variables to minimum, we get 3y plus y plus 6y as 160. Add all to get 10y as 160. So y is solved by dividing both sides by 10 and get y as 16. With one server already figured out, we can get the number of guests served by the first server from x as 3y. X is then thrice of 16, which gives x as 48. For the third server, we use z as twice of x, that is 2 times 48. So z is then solved as 96. The next problem has two caseworkers sharing an office. The first caseworker has 15 active cases. The second caseworker has twice the number of active cases. How many active cases does the office have? Although there are two caseworkers, it isn't necessary to assign two variables as the first caseworker already identified having 15 case files. So we only assign x to the number of case files of the second worker. Next is to relate the second caseworker with the first. That would be with x as twice of the first, which we know is 15, so x is 30. With the question of the summation of case files, we work on 15 plus x, and that is 15 plus 30 to get 45. Problem 5 states, a college has two depositional systems classes with a total of 237 students. One class has 45 more students than the other. How many students are in each class? We assign x for the number of students in the first class and y for those in the second class. Identify the relationship of the two classes. That would be y as equal to x plus 45. Another relationship of the two variables includes the total number of students. So we have x plus y as 237. Plug y in terms of x to have x plus 45 as equal to 237. Simplify the terms and get 2x plus 45 as equal to 237. Move 45 to the other side to have 2x as equal to 192. Take x by dividing 2 on both terms to have x as 96. The number of students in the first class. The students in the second class can be observed from y as x plus 45, which makes 96 plus 45, and y is simplified as 141. The sixth problem states, company employees attended the year-end banquet. 43 of the guests ordered chicken, while 12 more of them ordered steak, and 9 fewer ordered seafood. How many guests attended the banquet? There are 3 parameters involved. However, guests who ordered chicken is already known to be 43. Those who ordered steak is assigned as x, and those who ordered seafood is made y. Identify relationships starting with chicken as 43. Then for steak, that would be chicken plus 12. X is then 43 plus 12, giving 55. Seafood has chicken minus 9, which is computed as 43 minus 9, giving y as 34. To answer the question of the total number of guests in the banquet, we get those who ordered chicken, steak, and seafood. That would be 43 plus 55 plus 34, resulting to 132. The next problem has 3 taxi drivers working at an airport. The first driver transported 17 passengers in one day. The second transported 6 more passengers than the first driver, while the third transported 2 fewer passengers than the second. How many passengers did the 3 drivers transport? The 2 other unknown variables are then tagged as X for the second driver and Y for the third. Relating the passengers transported, we know that the first driver has served 17 passengers. The second driver has 6 more, making X as 17 plus 6, resulting to 23. The third has 2 fewer than the second driver, and that is 23 minus 2, giving 21. The total number of passengers transported is then from the first, second, and third drivers. That would be 17 plus 23 plus 21, resulting to 61.